All right, so I guess we're going to get started. So today's tech topic is introduction to Python and Django. I mean, I was trying to figure out what would be the best, introduction to what we've been working on in terms of, like, I think ours is the first project at Sound Exchange that uses Python and Django at Solution Street. So since Python would probably be new to everybody, I thought we'd go through a quick introduction to Python and then, just look at the Django framework, which is again a web framework for developing a framework for developing web applications using the Python programming language. So quickly, a few fun facts about Python. It was created by Guido, who's pictured here. Vinny said he looks like me if I was white and had a beard. So, and it was named after Monty Python's Flying Circus. Python 2.0 was released in October 2000, and Python 3.0 was a huge release, which was released in 2008, end of 2008, but it was backwards incompatible with 2.0, and so I think this has proved to be a huge kind of sticking point within the Python community. Like there was a lot of as Python adoption grew, there were a lot of packages created, but then most of them were not backwards compatible. They didn't run on Python 3, so Python 2 and 3 have been kind of trudging along, throughout. Apparently, 2.0 has been declared end of life by 2020, and but so we'll see what happens then. But like, for example, our project still uses Python 2.7, and I think Guido has declared that there's not going to be a Python 2.8. So none of the features will come, only security fixes and so on. So anyway, Guido is the BDFL. Does anybody know what that is? BDFL. Benevolent dictator for life. That's a term endearingly given to him. So yeah, Python is a general purpose, high-level programming languages. It supports many programming paradigms, object-oriented programming, which is very popular, functional and structured programming. There's also something called imperative programming that I didn't even know there was something like that. Which was on the, I thought that'd be interesting. Does anybody know what imperative programming is? We'll find out.
Declare what you want and it does it.
Yeah. I just saw it. Anyway, it's dynamically typed, which means you don't need to declare the type before you start using it. Python does have numerous implementations. CPython is the reference implementation, which is, I guess, implemented using C. There's an implementation that runs within the JVM called Jython, and there's another one called IronPython, which is a .NET implementation. So the thing about Python is, I guess, it comes with a core philosophy. The idea is to always, I guess, there's a huge focus on readability and making sure that code is simple and easy to read and pleasant to the eye. I think it's when you say something is Pythonic, I think it kind of follows this philosophy. They kind of frown upon premature optimization, like, you don't make things more complex than they need to be, or you just get to it and we go along. And it's like, it's built into the language. Like, for example, so for the first demo, if you start the Python shell and do import this, you get this, which is which is like almost like a poetry that is built into the Python language. Moving on. So it's a quick list things about data types. So Python supports, like, the normal data types that are like the numbers, integers, floats, big integers, longs, and even complex numbers. It has two string types, which is string and Unicode. I think that's one of the big things, the difference between Python 2 and Python 3. In Python 3, all the strings are Unicode by default. And in Python 2, you can convert between them. And that, we've actually run into some issues in our project related to that. There's also sequence types. So again, strings and Unicodes are also sequence types. And in addition, there's lists and tuples. There's also byte arrays, buffers, and X-range. But like in the last year, I haven't had the chance to use those things yet. Strings and tuples are immutable, which means you cannot assign part of it. Like, once they've been created, you can assign the variable to a new string or a new tuple, but you cannot change the tuple once it's created. So it always is a new tuple. I think that's similar to, Java. I think strings are immutable in Java. Lists are mutable, which means you can change the a single element within a list. It also has a dictionary mapping type, which is basically like a hash map type. So again, switching to a demo again. Let me fix this. It's a little small. So anyway, one of the things about you don't need to declare the type of a variable, but you cannot just access something without it being defined. So I'm just going to copy paste a few of these examples. So, like for example, if you try to access A, it's going to give you a name error. If once you've assigned it, you can access it. You can have a float type, which is automatically float, and then if you do a mixed operation, which is like integer and float, it figures out like the type for that, right? So it does conversions automatically. There are things like exponents, integer division, float division. So that's all kind of built. I mean, there are many math operations built in. So I guess over here you can see that x, because it's an integer division, it's just 3. Y, because it's an integer divided by float, the result is a float. That's it. And also there's type conversions. Like this is an example for conversion between the integer and a long type. For example, if you start like the sys.maxint is like the maximum possible integer, that's 2 raised to 63 minus 1. So you can see what it is. Right, and then if you kind of create a new variable and then you add 1 to that, it automatically gets the type long, right? So and that long type is indicated by the L at the end. So that's interesting. Right. So moving on with the examples. Strings first. So we have like string types. I mean, strings can be defined either by single quotes or by double quotes. If you have a single quote within a string, you can either escape it or you can use double quotes around it. So you don't need to escape the single quote inside that string. And these two are basically equivalent. So you can see B equal to C is true. You can do things like like something like this, which is you can do string operations that are kind of like math, but that's pretty straightforward. And a Unicode string, as we were saying, is it can be done by prefacing the string with a U before the quotes, so that becomes a Unicode type. And also like Unicode and strings are sort of equivalent, because like for example, if you do like over here we have A and U two. They're different types of type variables. Like one is a string, the other is a Unicode, but the equivalency returns true for those things. Examples, a quick example of lists. A list usually will be like a list of values, in a square bracket. The convention obviously is to have have all the elements of the list to be of the same type, but that's not enforced. Like you can have a list which has things of different types.
For the previous example, A is either triple equal, and that will come out with false.
No, there is not. And then we have list operations. Like for example, again, like if you have A, like if you do A0, you try to assign something to to the string. It's gonna. Strings are immutable, so you cannot assign a part of the string. But you can do that for lists. So we started with a list of cubes up to 5, but we had a mistake, so we can change that and we can add the next one here. So if you look at the list now, so the 4th element has been replaced, and then you have a new element here. So that's something. The list operations, the list also has the concept of slices. So you can basically manipulate parts of list by using an index range. Index range can be positive or negative. So just to give you a quick example here. So if you have if this is a list of letters, and if you want to change part of it, so right now what we're doing is we're changing like the values between the index 2 and 5, to something different. You can also, and again, when you change a range, it doesn't have to be the same number of elements. You can have less or more elements when you change a range. So that's that's going to just kind of swap out that part. Like for example, you just kind of remove 3 elements here. So now if you do this, so now those elements are gone. Same thing here. You can just, if you do use this, means you're basically clearing everything from the list. So now it's an empty list. There's a len function that is basically a utility function. It works on all the sequence types, so you can do a len of a list, of a string, of a Unicode. So that's basically something that we use very often in terms of whenever you're working with strings or any other sequence types. There's a concept of list comprehensions, which is basically an expression within square brackets which kind of creates a list. So for example, now we've created a list of squares for x between 0 and 5, because that's the range function. The range function basically will give you all the values starting with 0 up to that value, but not equal to. Right. I mean, you can do anything, right? I mean, any mathematical function, any operations for that element, right? Because I mean, basically, what will happen is that if you have range 10, that's going to give you a list, right? And then you can do, and then what we're doing here is that we are basically changing for each element in this list, we are doing something else. So that's doing that operation. The range function also has like you can do starting, ending values, and steps. So so that's another thing that you can do basically. So it's basically based on the number of parameters you pass. There are different things you can do with the range function. So for example, here we starting with 3 less than 10 in steps of 2. So that's what we got. So tuples are basically just a sequence of values follow separated by a comma. If you look at a tuple, it's represented using parentheses instead of square bracket. They're similar to lists, except that they're not. Again, they are immutable, so you cannot assign a part of a tuple to something. Like you wouldn't be able to do this. And tuples are I guess used like very common in Python usage. Like they're used to also like to make the lines of code that you write. You can have multiple assignment on the same line, things like that. Like you can, like for example over here, what we did was basically we assign x, y, and z to the different values in the tuple. Like x is 0, y is z is 2. Similarly, I mean we have Python also has a native set type. So a set type is basically it's basically a list which has everything is unique within that. So over here, for example, we have the apple appears twice, and so that that's only once in the set. So that's a set type. I mean, we haven't happened to use much of the set type, but it's something that I thought I'd show here. And finally, I mean, the set comprehension, which is you can create a set similar to list comprehensions. Right. So dictionaries, again, the Dix type is a mapping type, which is again very common in programming languages. So there is a native type here. So if you do the same, so over here we have like a very simple mapping, and you can if the keys are simple strings, you can also use a direct like a notation like the one on the last line here. So that's pretty much similar to to what the line above that says. Mm-hmm. Also, I mean, there are simple things like you can create a dictionary using like the comprehension notations. For example, over here we have a dict which is basically mapping the numbers to their squares, and then you can see the keys, values, and then each of the items is a tuple, which is a key value pair, essentially. So that's basically about dictionaries. Python does support functions. I mean, functions are just defined using the keyword def, followed by the function name and an optional list of formal parameters. The statements form the next line. Again, in Python, one of the things about Python, there are no brackets. The blocks are created using indentation. It's usually 2 spaces or 4 spaces. I mean, that's up to the programmer to decide. I think we use 4 spaces because I think that's more legible. That's what the statements also have the concept of a doc string. So the first statement in a function can be a string literal. So that's essentially the documentation for that function. There's also the concept of doc test that we cover later. I just created one quickly earlier today. All the arguments are passed by value, but in terms of in objects, it's passed by its value to the reference. So it's almost like a pass by reference. The functions always return a value. So even if you don't have a return statement, then the functions will return none. I'll just go to the next slide right now quickly, because I'll cover in the next set of examples. Again, there are very simple control flow functions. There's if. There's an optional elif and else after an if. That's elif is nothing but just an else if. It just makes it a little concise to write. There's a for statement, and then there's a while statement. We use range, the range function we saw earlier, and then there is break, continue, and else. I mean, there's an else. The first time I've seen something which has a for, which has an else statement, which basically is used to for something in terms of at the end of the for loop, if the for loop completed and it didn't break at some point, and then the else is also executed, which was interesting, I thought. So one of the things about Python is that the concept of truthiness. I think that was the coin. I think first time I heard that word was when Stephen Colbert made it famous. He was talking about things that feel true but are not really true. So that's something that Python also I guess follows. But in terms of like over here, it's more like falsiness, because all these things in this list over here will evaluate to false, like things like an empty list, an empty tuple, an empty dictionary, an empty string, the number 0, of course, the object none, the Boolean object false, obviously, and then also objects can define their own behavior too, when they might evaluate to false. Modules and packages, quickly. A module is basically just a file that contains Python definition and statements. Any Python file is essentially a module. Like, I think that's different from Java, in which like each file is usually one class. In Python, you can have like arbitrary functions and classes. I mean, I know you can have multiple classes in the file, but I think the convention is to have a single class per file. You can have like you can have statements, you can have functions, you can have classes, all within a module. There's a special variable called name. That's a global variable for the module that is set to the name of the file usually. But when you execute it using the script, it's set to main. So that's essentially what becomes the main function for a module if you want to execute it via a script. And so again, packages are just a way of kind of organizing Python modules within. So you can kind of nest them, in multiple directories, and you can have them available to other modules and other files. So a quick example of a package would be here. So for example, over here, the file over here is called Fibonacci, and it's basically this module just has a function. And over here you can see the name is there's a piece of code here which is executed when you execute this module, and over here it says if name is main, you call the function with the first argument that is given to it. So you can execute this basically by using something like this. Sorry. Out of here, if I do. So if I do this, so now basically what I've done is executed the Python file with the value 100, and you can do the same thing over here. Like if I do, package. So essentially, that's the same result. And the other thing is over here, like on the print function here, appending a comma at the end of the print function makes it not go to the next line. So that's just a tidbit, I guess, over here. Okay, quickly to classes. Again, Python is class mechanism. You can add classes with with a very simple syntax. They provide all the features of object-oriented programming, where you can have inheritance, multiple inheritance even. You can have a child class and a base class and a base class. Sorry, a child class can override methods in the base class, or even call methods in the base class which have this with the same name. You can have arbitrary amounts of data in the class, and there's a difference. I think one thing that is kind of interesting about Python is the way the class and instance variables work, which I'll quickly show, and then there's static methods, of course. So quickly going to the example for classes. So this is a simple class. You can just have this is a class variable. This is a function which just returns hello world. I'm going to skip this example and go to the next one. So over here you can see that there's a class with a variable tricks, which is an incorrect use of a class variable, because what we want is the attribute tricks to be associated with each instance of the dog class, not the dog class directly. So if you, for example, I'll just execute this piece of code quickly. Right. So if you do. So now you can see that even though you added a trick to the different instance, each of the two instances will have each of the two instances will have both trick values. So this was something that I think we kind of stumbled upon when we started with Django. I mean, it's variable, but it's actually a class variable. So that's something to be kind of wary about when you start with Python. So of course, like the way to correct that would be to just do this. So over here now you have correct variable. Yeah. So the other things over here to notice is that there's a special function called Init, which can be used to initialize the class instance. So that's essentially the constructor with optional arguments. You can assign the name here. You can go here. And then, of course,
arguments in function call.
Yes, yeah, you can do that. You can default arguments and everything. Yeah. Yeah, I missed the part about some of the functions. Yeah, I think that's when my computer crapped out. Anyway. So anyway, I just want to quickly just go back to the functions quickly. So here we have like the way you can call functions. The way arguments are passed to functions. We have. Let's see. I'll just quickly execute a bunch of code here. So when you say, like, when you just give it a name, the default the TV show to Breaking Bad, and it prints it out. Args and quarks are nothing. And the same thing you can over here in this line over here you can see. Over here. I pass like arbitrary values after the two named parameters, so that goes into the args list. And then if you do if you have a named parameter after the arbitrary list, that goes into a different variable called quarks. So that's basically like a dictionary that gets formed. So you can create functions with you can have formal parameters that are named, and then you can pass arbitrary values that you can check for. So that's also very common to use. You don't have to. You only define very things that you are sure about, and if you have optional list of parameters, you can just use args and quarks to check for presence and then do something with that.
Why does the quark have to start with args?
I think that's just the syntax. I think it's it doesn't have to be named quarks, but the 2 stars. I think it means you collect that in a dictionary. Yeah. So because it's a dictionary, because I think that's what tells the function that anything that is any named parameters that don't match to any parameters that are key value pairs, should be placed in that.
Can you reverse those? If you had reversed args and quargs, would you get your name parameters, your vargs, and your any extra after that?
No, I think it has to be in this
So
order.
they have to be
In this order.
the
Arjun, I mean, yeah, I'm not exactly sure, but I can probably get back to you about that for sure. But that's a good question. There was the Python meetup had like a whole session on args and quargs, so it can get quite hairy. Anyway, I think just in the interest of time, I'm going to speed along. So anyway, so I mean that was just the introduction to Python. So Python has like a very vast standard library. It includes packages and things that you can use for many of these things like operating systems, file handling, collections, unit tests. I think this is because this philosophy. One of the things about the Python and I think that goes on to Django is I think they go with the batteries included philosophy. I think they give you as much implementation as as is reasonable. We did find, I think recently there were a couple of things that we were looking for that we didn't find. So I think this might be disputed by some of the members of our team, but but I think that's the philosophy. Anyway, moving on to the next part, Django. So this was something that I had to put here because every time when we started, the movie just came out, and anytime you search, Google Suggest would just splash this image in our face. So it's only fair to show it once at least. So Django, again, it's a web framework to create. It's a framework to create web applications using the Python programming language. It basically grew organically from real-world applications. It was basically started up as something that the two guys within the newsroom used to quickly create web apps on a tight deadline. So it was basically created in what's it called? In Lawrence, in Kansas, in USA. So the two guys, Adrian and Simon, these two, they were basically shepherding the project for quite a while. I think recently one of them, I think one or both of them stepped down. And I mean, it has like thousands of contributors now, and there's a huge list of core committers, just like Rails, I guess. But it was named after a jazz guitarist because I think Adrian Holovati is he's interested in that kind of thing. It's for perfectionists with deadlines. I think that's what they say. Getting started. Installation is pretty simple. It's just pip install Django. I didn't want to spend too much time on that right now. Anyway, we're short of time. So you might have to install pip, figure out and kind of go back and make sure you have all the prerequisites before you are able to install it. Once you've installed Django, it's pretty quick to get started. They have a very cool admin function that gets you started up quickly, so you can create projects. So the idea about the way that a Django project is laid out is there's a project which is a website, and then you can create apps within that. So I think that's the way it kind of uses. When you create a Django project, you get a bunch of apps by default, which are used for many things like messaging, for authorization, authentication, and so on. And then whatever you create, like any business logic, you put in your own app, and then you add it to the list of apps. And you'll see that shortly. So this is an example that we'll be going through. I basically created a very small music catalog, which has songs, artists, and albums, and we'll just go through that as part of the example. So the Django framework basically operates just like any other MVC framework. It separates the separation of concerns. There's models. These are the files that are commonly used when you start up a Django project. So that's why I've used those names here. The models obviously are the model objects that that kind of map to your database table. That's the data of your application. Views.py, and it contains a business logic for the page. This was another kind of you had to kind of wrap your brain around it because the view is essentially the part. It's not the template. It's actually the part that makes the template. So all the business logic. So there are view functions and not the views. I think like for example, if you look at Spring MVCs, I think JSP is the view, but here the views are functions. And then there's a module that lets you map URLs to view functions, so you can your app can execute and so on. And then Django has a very strong templating language that comes built in if you want to use that. So that's basically, you can use templates to describe the page. It has basic logic, variables, things like that. I think that's similar to what we would use like beans in Java, like you would set something up. I think that's Ruby on Rails uses the same philosophy. So quickly, the models.py, you can have each model is represented by a class. You subclass a Django model class. The variable, there are class variables within the model object, and each of them basically map to a database field. The name of the field is the same as the database column name. You can all these are defaults. You can change most of this behavior, like in terms of the naming of the fields and so on. So then what you have is that basically each field is also a class. So you can use, so there are types defined for a field, like if there's a character field, there's a char field class, and then there's integer field, datetime field, and so on. And each of them take, some of them take, required arguments. Like for example, if you define a character field, you have to give it a max length. In other cases, you can define defaults that are optional. You can define whether it's nullable or not by optional. If you don't define anything by default, it's non-nullable. So if you don't, define nullability true. There's a foreign key type that can be used to define relationships. And then you can support many-to-one, many-to-many, and one-to-one relationships. Let's go back to an example. Okay. So, I mean, I'm using a virtual environment which has my Django, so I have to just activate that. Explain that too much. But anyway, so here what we can see is, like, just to go through some of the simple things that you can do with the model. So I'm just going to, one of the neat things about Django is using the manage.py. You can activate a shell which you can use to interact with your Django, with whatever you've defined within your Django program. So you can basically do everything in the command line. So the way to create artists is very simple. Like you can just let's see the model first. So anyway, these are the models that I've defined. It's just an artist, album, and a song. We have a song can have and optionally and be associated with an album or an artist. An album will have a name, genre, and release date. And that's something that you can do later. So that's what I have here.
So you're defining your columns as, like you showed before with the trick example. These are all class variables.
Right. So these are all class variables, and the data is stored within the model object in a separate instance variable.
Can you generate these from the database?
I'm not sure. I think the way we do them usually is you start them here and then you
create the database.
Right. So I don't think Django supports that. I don't think you can do that. You can, yeah. I think the way you do.
We have in the Django.db
I'm sorry. Can you repeat it?
Django.db. What do you have there now?
Yeah. So that's the models library. So I think that's basically like the Django framework, right? So you have to. So basically you're importing models, and then every model object has to extend the model class for it. Yeah. So that's basically the package that you import, and then you use classes within that to extend. When you create your own classes.
So that's how you do inheritance.
Yes. Oh yeah. Sorry, I guess I didn't cover that. But yeah, that's how you do inheritance.
It's normal to put multiple classes in one class.
Yes.
Do you usually or ever have to do multiple inheritance? Because a lot of languages don't allow, but Python seems to.
Yeah, Python does allow multiple inheritance. I mean, we haven't had the chance to use it yet. Like, we didn't really run into any scenarios that require that. But it does support multiple inheritance. Right. So going back to the example here, you can create what I've done over here is just create an artist. You can save it to the database by just calling the save method. So now if you do if you query it, you can see that now you have right, the last update is here. Sorry. So you can do that, and then you can edit it in the same way. So now it's sorry. So the name is changed here, and then if you can even delete the objects in the same way. And then if you do this, it's gone now. It's not on the list anymore. So these are the different ways you can query objects. So the way that you query objects is that you use the class, because you have to. I think that the objects word, like, I mean, the keyword here is basically the manager object for that, for that model class, and you can use different ways to query it. I mean, each of these things are basically queries over here. So for example, over here we have like, for example, there's a get method which you can use to get it usually return a single object. The filter method will return like a list that matches it. If you use a get with something that doesn't match, it will throw an error. But if you use that with filter, you just get an empty list back. So that's something that that is useful to know whenever you're looking up stuff. And then you can use things like you can filter using arbitrary criteria, like you can on the names. The name contains T, so that that works. You can also query related objects. For example, over here we have like in this example over here we have like the band Metallica, which is the first artist. You can get the song set by using the song _ set. It's a reverse lookup because the artist is set up on the songs object. So when you look it up from the artist point of view, you have to just use _ set, because that's going to give you the artist set. And over here, what we've done is from the song set for Metallica, you can look up a song which is Enter Sandman here, and then you can look up the album for the Enter Sandman by just doing .album, because that's defined on the song directly. And then same thing, you can look at for each album, you can get all the songs on it. So that's basically a few of the queries. You can also you can save related objects. Like if you create a new song, like over here, I can save it on an album, right? So now if I do this, so that you have the new songs in there, and you can do the filter criteria over here is like it's always an and. So you can have, like, for example, over here you're filtering artists by the song name, which contains the word Sandman and ID equal to 1, which I know because I know the ID for the Enter Sandman is 1. But that's basically an and condition. But if you want to use or, there's something called a queue object that you can use, and this is the notation basically that you can use for or object. So basically, this is just a demonstration of what you can do with this. And there's raw queries. If you don't want to use the Django generated queries, you can just do raw queries. So in this case, because we are calling the raw query using the artist model, you can it'll basically instantiate artist objects, and you can access them from the raw query set. There are other things you can do, like you can run arbitrary queries that are not related to any model, and you can get the values returned are usually just list of tuples of tuples or list of tuples, or a sequence of tuples, and then you can just access the values from within the query.
Is there a way in the console there to see the sequence being generated by when you're using
the query?
Yeah. Like in Rails console, you can see.
There's probably is, but I don't know that off the top of my head. In the logging, you can cover that. Okay. So yeah, we covered basically we covered the models and the queries.
Were you going to touch on the settings file, and how it ties together, how it's database?
Right. Yeah, I was going to do that. I mean, I was just going to the models, and then we look at the app again. So migrations is something that is new in Django 1.7. Before that, it was basically done using an external external package called South. But we are still using Django 1.5. But for this example, I use 1.7, so we can just so that I can demonstrate this. But basically, you can keep the database in sync with your object model. Whenever you create a new object type, you can use this. When you create a new field, or you could delete a field or so on, you can create a migration. It has simple migrations called migrate. I mean, you can migrate, run the migrations, make migrate, create the migration. SQL migrate shows the SQL that will be run for a migration. So I know that you can do that for SQL for migrations. And then if you want to do data migrations, there's no explicit support for that, but what you can do is create an empty migration and then modify the migration file before you run the migration. So, see that. So just a quick example for that would be, so if I add a number sold to the album here, I can go to the command prompt here and then run migrations. So now it's going to create a migration here, right? And then if I do yeah, so you can see over here, like we have, this is a SQL that will be run when you add the number sold, a column to your music album.
So you would change your model to what you want it to look like, and then when you run the migrations, it's introspecting the model. So
right.
What's changed.
Right. So you can see them. I mean, you can see the migrations over here. So that's how it, does that. Yeah.
So does this only work for SQL databases, or can you connect to a SQL database and run migrations to the database?
I'm not sure. I think it runs only for SQL. Yeah, because it generates SQL, right? I mean, it's not anything you can do.
So when you do the migration, you also handle the relations like
Right. So if you do something that's going to break something, it's going to warn you and so on. I mean, I think they do as much as it can to kind of keep everything in sync. I think it's similar to Rails, right? I mean, they do that.
Can you roll back migrations?
Yes, I think you can. I think there's a way to. I don't know the command off the top of my head, but like in South, for example, I mean, they used to have like two methods called forwards and backwards. So the way, so you can see clearly what happens when you roll something back. But over here, because this is new, it just it just has a migrations add field class, and I think it probably when you try to roll something back, it does the reverse of that. It reverses that change. All right. So URLs.py, I mean, so that's basically the routing module, which basically maps URLs to view functions. It uses a URL configuration module called URL-conf. It's a simple configuration between URL patterns, which are basically regular expressions, to view functions. You can capture parts of the URL as a parameter and then pass that to a view function. So we'll see an example of that. You can, it's basically just Python code, so you can, run it dynamically as well. So let me just cover views too before I go to the example. A view is basically just a Python function that takes a web request as a parameter and returns a web response. The web response can be anything. It can be a redirect, HTML page, an XML page. I think Django 1.7 added like a JSON response type, so you can now natively return JSON. The convention is to put views in a file called views.py, but it can be pretty much anywhere. And Django does provide a bunch of shortcuts to make view functions easier to work with. Like there's functions called to redirect to render something to the response using an HTML template, and optional variables set up on the template. And also you can do reverse lookups. So the reverse is used to do reverse lookups of URLs. So I will just see a few examples of that quickly.
When you send a request, does it hit the view first or the controller first?
It uses it basically goes with so I think now is probably a good time to just go through that quickly. So when the Django settings file is basically the starting point for the Django for the Django app. So it does define like a variable called root URL conf, which is basically the starting point. So that's basically where the request starts. So anytime you get a request, it looks at the URLs file to figure out what matches and then which view function to call after that.
Okay, so it's routing then views, not routing and controllers.
Right.
Okay.
Yeah. I mean the view is the controller, right? I'm not sure.
Well, I guess it's a little different in Rails because you can get like a controller then before you get to a view, you can redirect you to a different controller.
Right. I think the way I kind of explained that to myself when I started was like the views.py is the controller. So and that's what you can use to bounce around.
Does Django have controller? So?
No, I think that's the controller, right?
Oh, okay.
Yeah, that's the controller. So the views.py is basically the controller, right? So, right. So over here, like this is a very simple example of a URLs.py file. So over here, as you can see, it's a regular expression where we can have there's a simple hello world, which is basically just hello, after the server name that maps to the function hello, which again this view function over here just returns a simple hello world to the page. So that's usually where we start. So that's basically it, right? So if you do hello, it's the same thing because I've mapped both the URLs here to the same function. These two functions here. So the next thing that over here that you can see is that you can basically nest URLs. So basically over here, what this line does is that it says anything that starts with the word music, you can you delegate to the music URLs file. So that's where you look for the rest of the string that matches any of the URLs. So that's what we use here. So if you do music, I mean, it just gives an example music catalog here because that's what this, when you have nothing after that, it just matches the music home function, which, it just renders the home.html file, which has nothing but the example music catalog. So that's what gets rendered over here. So I think I'll just cover the rest of my slides before I go back to the example and show everything else, so we can get through it with. So Django templates are basically designed to basically you can create HTML file and then you can replace bits of it with the dynamic content. It does Django templates also. I think they do as much as possible without trying to break through like the purpose of templates, which is just to show data. So you cannot execute too much, control functions within something that you should be doing within the view is not possible to do within the template or within the controller. So I think it's kind of limited in that way. It kind of forces you to, do whatever you need to in the right place. There's a concept of variables, which is basically they replace the values when the template is evaluated. The dot in a variable is basically used to look up things like execute a function, look up an attribute, or if it's a list, you can use an index in there. So it's basically multi-purpose. I think the template kind of figures it out at runtime as you go along. So these are examples of what you can do here. Filters can be used to modify variables for display, which is basically like anything that is after a pipe. You can pipe the variable to a function, which can be used to format values for display and so on. Like for example, that's an example of making the name lowercase if you want, if that's how you want to show it. Okay. Right. So the templates you can use tags to control the template. The commonly used tags are for, if, and block and extends. Block and extends are used for template inheritance, which is basically a way to nest templates. So I think that's similar to tiles, except that I think it's much more dynamic and easy to work with. At least that's what I found. The template inheritance is the most powerful part of the Django's template engine. It basically you can build a skeleton template, and then you can define blocks, and then you can then you can have other files that extend the base template and replace blocks. The idea is to kind of just use as many blocks as you want, even if you don't want to. You may not replace each of them in your in the child templates, but you can have reasonable defaults, and we'll see. I'll just show you examples of that right now. Let's do that. So going back to the music function over here, what I have here is basically just a list of albums, artists, and songs. You can what?
You're gonna run your migration?
Yeah, I didn't remember. So that was the problem. Anyway, so we have these things here. It's pretty basic. So I mean, the way this is done is basically using URLs and views functions, as I can show quickly. So here we have like the albums URLs that map to the list albums function, songs, artists, and so on. And then I have a separate function that basically you can look at the songs for an artist, the songs for an album, and then also we can have edit album. And each of them, as you can see, it captures the artist ID parameter here. So if you go through this view function, you can see, the artist ID is basically a parameter to the view function. You can use, and it's always a string. So here you have to first convert it to an integer, and then you can filter it based on that, and then you can find the artists and the songs, and then you can use the render to response function is something that can be used to basically set up the template. So over here, it accepts a dictionary with the songs and the artists. So that's basically it. And then if you look at the songs template over here, this is basically the template. It extends base.html. Base.html is basically the base for the template. It kind of defines the container for each of the HTML files that will be rendered. We have the music, the navigation bar, which appears on all the pages, and then it defines the block, which this content goes here. So this is basically the only part that needs to be overridden everywhere, because everything else, it'll work pretty much. I mean, it'll work regardless, but you'll just see content goes here, which won't make much sense. And then I'm using these nav artist block to optionally kind of show the navigation bar as active for the page that you're on. Like for example, if you go under the albums page here, just this block over here, it defines the same similar block except with the class active. So because when you do this, you can see. So the others are the defaults and everything else. Right. And then if you click on the songs here, it creates the URL, and based on the URL, it goes to a different view function that just looks up that particular list of songs.
Can you set a global base template so you don't have to define it on every file?
No, I think you have to just do this.
You have to specify it.
Yeah, you have to extend it. That's the way you have to do it. So anyway, so this is the last bit of the presentation. Django has support for forms. Obviously, I mean that's very common in web frameworks. It handles most of the work. I mean that needs to be done with forms. Basically, taking the request data, creating a form object out of that. You can use the form objects to also render the form on the page, and then you can also covers validation. It's similar to the model field, in which like each element is a class which can be used to figure out. You can use a specific class for a specific type of element that you want to render on the page, and then they are basically rendered on the page using widgets. So over here, what I have is a form for editing an album. So as you can see over here, we have what I did was just a hidden input field for the ID, which you can use if you want to edit a form or create a new album. The name over here is a character field, it uses a text input widget, which is a default, but we had to define it here because we're using Bootstrap and it needs to render with a particular class, so you can pass things to the widget when you render it. And also it takes a default label would be name, but if you want to call it something else that is different from the variable, you can pass it in over here. For example, over here I've called it album name. Over here, so based on what you define over here, the validation will be done automatically. Like for example, max length field is 30. So if you do something more than 30, the default validation will take care of most of that. If you want to do something that is more than that, you can define your own custom validation functions, and they follow this convention like clean underscore the name of the field for a field, and you can also do validation that grows across fields. So in this case, basically the genre field does not allow special characters, and if if it finds something that is wrong, it'll raise this validation error. So if I go here and I try to edit something, it gives me this validation error. And the way this is rendered is all done using like the Django template. So going back to the edit album HTML page here, it uses, so whenever you have the form and the form is created using the request, I guess I should show the view first. Right. So this is the edit album function. So you can see over here, if the request is a get, you basically go into that page. If it's a post, you're basically that's the part that is trying to make the change to the album. We have the is valid function of the form basically executes the validation, and if it's valid, then we make the changes here. Otherwise, we render the response. And also, what we do here is using the messages framework, which is something that Django builds in to put a success message that kind of survives a redirect. So I think this is similar to Flash, I guess, in Rails. And then going back to, so now that we have rendered the page over here with the album form object, you can look at over here, kind of using the template to render it. So the ID field is rendered as a hidden field. You can just use the variable notation to kind of just render the ID field. For the rest, I'm using a snippet, which is basically again, this is something that you can use to kind of, if you want something that looks similar. So what this does here, the form field is basically like a Twitter Bootstrap based block, that renders the form field. So this is something that I think this is mostly straight out of what we use in our app at Sound Exchange. So it kind of, you can look at each field where the label is rendered, and then if it's required, it renders an asterisk. It renders the field itself, and then if there are errors, it shows the errors. And the form control class, basically, that's how you can get something like this. You can use what Django also allows you to do is also, like, it has helper functions to just render the whole form as a table or as a list or as a paragraph or something like that. But you almost never can use that because you want your things to look nicer than that. Anyway. So again, Django also has a lot of built-in functionality. It covers authentication, authorization, sending emails, file upload, session and management caching, transactions, and so on. So I think we found it to be very productive. I think when I started working with Django, I think it took me maybe 2 weeks, and after that, I was productive for maybe a couple of months. I was doing things that were not, maybe you shouldn't be doing. But I was productive. Things worked. Maybe it wasn't Pythonic, but I figured it out eventually. I think now we have a pretty good handle, I think, on Django web development. It's pretty fun. So. And there are things that I didn't cover just because we're already way over. So the admin app has a bunch of functionality that you can use to help when you're doing development. There is a thing called model forms, which are basically forms based on your models. So you can quickly create model forms. There's generic views or class-based views. So right now, all the views we saw were like basically just function-based views, but you can have generic class-based views to do things like, like for simple CRUD operations or list operations or search operations, you can use something like that. Static file deployment, which is something that is used for, if you have static files, you want them to go through the, the web server directly, and you don't want to, them to go through the Django framework. There are things that you can do to, to improve performance that way. Settings, I can quickly cover that actually. So the settings is basically where you define a lot of the things about your Django app. Most of these things come, in the default app. Like the only thing that added here was the music app. Everything else was included by default. Of course, you can take things out as you don't need them, but these are the things that you need in most apps. The admin app, usually you take it out before you deploy to production because you don't want the admin functionality out there. And things that, this is where you can define a database. By default, it defaults to SQLite, but, I just switched it out to use MySQL. You can do that pretty easily. There's things like time zone, support for internationalization, and showing whether you want to use time zones or not. And just switch time zone to a current time zone from UTC. Also, you can, like, for templates, you have to define the directory where your templates are stored. So that's one of the settings over here. These are just a list of references, questions.
Did you find most of the business logic in the view file or the model file?
No, I think what we ended up doing was basically created a separate file, like a services.py module where we put all the business. So I mean, I think as you have a bigger app, I think if you have a very small app, you can probably put it just in the view. But if you have a bigger project and you have like things that you don't want, like, so what we did was basically use the convention where the views.py was just doing things for display, getting the user request and preparing the template, and everything else goes to like a different module. So you can just define that as a separate module.
Yeah, to that, it seems like you.
Not in the model.
Yeah, not in the model, right? Yeah, not in the model.
Seems like you get a lot of contention because there's a small number of files in terms of team development, like model stuff. Like, seems like you should have a file for each model. Is it possible to do that, or did you guys have any contention issues?
Actually, I mean, it's possible to do that. Obviously, I mean, you can have that, but we didn't really have any contention. I mean, practically it didn't work out. I mean, we were working on different paces, and I think with Git and everything, it was even without using extension. Yeah. And I think the contention was some of the services file or like a business logic module that we created is pretty big. I think that's where we found a lot of contention, because models are, I mean, for things like that, you don't changing them as often. Right? So,
Yeah, the business logic is not in the model.
Right. Right, and basically we created modules for everything. For example, we created like a services, which is the first pass, but then if we had transactions, that went to a different module. For Salesforce operations, we put them in a different module. So we kind of tried to modularize as much as we could. I had to put an animated section. All right, thanks everybody. What? Just okay. Oh, that's Sherlock. Benedict Cumberbatch.
Oh, there you go. Starts there, right?
Where location.
Yeah, he's in static.
Usually with the